All right, welcome back to another awesome application of quadratics, and I hope that you're having a great time doing these. In the last video, we solved a calculus problem without actually using calculus. We used what we know about quadratics. We're going to do the same thing here, but this is a very underrated problem, very rarely used in Algebra 1 or Algebra 2 courses, and maybe rarely seen in pre-calc. But I am the calculus teacher, and I teach this in calculus, pre-calculus, and every algebra course that I've ever taught. So here's the way that I approach it. Here's the main idea, all right? We want to be able to represent the area of the rectangle in terms of x. Notice how it's not a 7 by 3 rectangle or a 2 by 8. Our length and width are both represented by some variable x. So that's what it says represent, all right? It's not going to be an actual value. I don't have any room to write the equation here. I'm going to give you this time, and I always like to be mindful of your pacing and your own time, thinking time. So if you want to pause and try it by yourself, do it right now, because if otherwise we're going to check it right away. Let's do it. Here's what I mean by represent. If you didn't know what that meant, then you weren't going to pause anyway. Just think of how would you figure out the area of a rectangle? We would do the base times the height, base times height, or if you want to think length times width, length times width. So in whatever order it would be, I like to write in this order, x times 10 minus x. There should be a minus sign there. There we go. That is the base times the height, base times height. There it is. That's what I mean by represented. So this part is done. Now from there, hopefully you recognize, I do recognize that this is in factored form. If you do recognize that, then you don't have to go to the trouble of distributing this into standard form. And at the same time, hopefully you visualize this negative x. This means negative something squared. So start thinking about the way that this parabola is going to curve. And the cool part is that whatever graph we make down here is going to represent, that parabola is going to represent what the area of this rectangle is doing as the value of x changes for certain values of x. We'll see not any value of x is going to work, only certain ones. So let's see what happens. Keep up what you know about geometry and areas in mind, right? So let's go to the next part. And because we recognize this as factored form, then we know that it's something times something. What makes the first one equal to 0? When x equals 0. What makes the other something equal to 0 is 10 minus something. Be very careful. 10 minus something is not negative 10. It's when x equals 10, because 10 minus 10 is 0. And if you were to distribute, I won't do that, but think x times negative x will give you some negative x squared term. So we know this has to be a curving down parabola. But before I even do that, I'm going to focus on, all right, we know 2x intercepts. This is 10 and 0. What's the midpoint between 10 and 0? Which is the main important thing about these type of graphs. We're going to say that x equals 0. I'm sorry, x equals 5 is the line of symmetry. And that's what's going to help us achieve, find our maximum point, which I think is what's coming up next. Good. And it helps us make our sketch anyway. So it's a good thing to do. That's what I would do, and ignore this and then put the pieces together later. And hopefully you're visualizing that graph. As soon as I see that, I'm going to start plotting, connecting those dots. We know there's some curvature and it's downwards. Symmetry on the right side. Let me redo that again. I'm not very satisfied with that, but I get another chance right here. There we go. And here's what I want you to keep in mind. What can be true? We're not graphing x and y anymore. We're graphing area. What is true about area in terms of positive and negative values? Can area be positive? Yeah, so this graph, part of the graph makes sense. But can area be negative somewhere down here? And the answer is no. So therefore, I'm just going to use dashed lines to represent that that's not going to fit this model, but it helps us visualize the symmetry on both sides. And same thing here. It's not really part of the problem. This part of the graph doesn't make sense with this problem anymore, but hopefully you can see that nice symmetry. All right, we know one thing about the maximum value, which I think is the next part we need to figure out. It's saying, what is the maximum? That's the calculus typical type of problem that you would see in that course. What is the maximum possible area of this rectangle? We at least know that it happens when x equals 5. It happens at the vertex when x equals 5. So 1c down here. And then this is saying, what is the area of the square when x equals 5. So really we want the area when x equals 5 to figure out what that is going to be. And remember that it was something times something. X is 5, so therefore I'm going to write it as 5 times 10 minus x. If you're confused about this, maybe I should have written this first. Remember that a of x, the original equation that we wrote, was x times 10 minus x. And then we made these substitutions. Boom, there it is. So we can say that, all right, we have 5 times 5. So the area happens when x equals 5, and it is 25. Remember that this represents a point on the graph. It is 5 comma 25, which I'm going to fill in right here. That's the maximum value possible for area. I hope that makes sense to you, because we have one last thing to do. And it says for letter 1D, for what values of x is the area 16? So remember that this area means a of x. And 16, we need to make an equation. When is a of x equal to 16? We already have the equation right here, so all I'm going to do is make a substitution. We know that x times 10 minus x is 16. And this is a quadratic equation that hopefully you can feel comfortable approaching. Because this is not equal to 0, therefore I am going to distribute. We have x times 10 gives us 10x minus x squared. Verify that for yourself at your own pace. X times negative x is negative x squared. And now I do want to see if I can factor this, but rather than subtracting 16 on both sides, then we would have to deal with that negative. So what I'm going to do is make the left side equal to 0. Visualize this for yourself. We want to undo the minus x squared. We're going to add it to both sides. Plus x squared on both sides should give us x squared. And we want to undo the positive 10x. How do we undo that? By subtracting 10x. And on the right side, we are still remaining, right side of the equation, we're still remaining with a positive 16. Just verify that those two are the same. Take your time. And here we go. Let's try and factor that. Think of product and sum idea. Since there's no GCF. X times x for the x squared term. And then what two numbers can multiply to 16 and combine to a negative 10? It must be some form of 8 and 2 when they're both negative. So therefore x equals 8 or x equals 2. But be careful. What is their y value? Remember that this now represents a y value. So it is 8 comma 16 and 2 comma 16. Since their y value matches, they are points of symmetry or matching points. Let's see how that looks on the graph. We have 2 comma 16, 2 comma 16 right there. And we have 8 comma 16 right there. That looks very close. I was pretty close on my accuracy. This one, of course, is the 816, and this is the 216. And like I said, matching points. This distance of 3 units 2 times. 3 units on the left side and 3 units on the right side of the line of symmetry. Look for those things in all these quadratic equations. All right, I could talk about this problem for another 10 minutes, but we have maybe 4 or 5 more to go. So let's move on and you try and digest this at your own pace. All right, next thing is a more advanced version of this problem, but it's the same idea as we want to represent the area in terms of x. We want to write an equation, sketch it, find the maximum possible area of the rectangle, and figure out for what values of x is the area going to be 81. But hopefully you see there's more going on. It's not just x, it's 3 times x. But still we think base times height. What's the equation? Let's write it down here. The equation is going to be the base, which is 12 minus x, times the height, which is 3 times x, or something times something. And from that we can determine, before I even read this, I'm just going to go straight to graphing. That's what I think when I see this immediately. What value makes the first something equal to 0? 3 times 0 is the only thing that gives us a 0, and 12 minus 12. I guess this is 14. I didn't write it in. All right, and then before I even read any of this up here, I'm still thinking, what is the midpoint or the line of symmetry for this? 12 divided by 2 is 6. And then I'm thinking, is it a curving down or curving up parabola? Positive 3x times negative x is negative 3x squared, so therefore it is curving downwards. And it only makes sense because we're looking for a maximum. A maximum only makes sense if it's a curving down parabola. Think of any parabola that curves upwards. It doesn't have a maximum. Those have a minimum. So that's a big hint in itself. And remember the idea we talked about, area cannot be negative. In the context of this problem, area cannot be negative, so it would look something like this. But at least we know that x equals 6 is the line of symmetry. So 6 comma something must be the maximum area. Remember, this parabola represents the area of the rectangle, and the y value, if you think of that way, represents the area. So we want to evaluate letter C. We want area when x equals 6. And the factor form says 3 times 6 times 12 minus x. So I'll let you do that at your own pace. That is 3 times 6 times 6. Which I think is 108. Verify that for yourself, and then give you some time to try the next one. See if you can do it before me. Letter D. All right, so remember that now it says, for what values of x is the area 81? And that makes sense. 81 is smaller than the maximum area of 108. So it has to happen somewhere down here. So you should keep that in mind. Our answer should make sense. And this means that we want the equation of the area equal to 81. And we do have an expression for a of x. We wrote it up here. So we're going to say that 3x times 12 minus x is 81. And hopefully your factoring skills are strong because they're going to be required here. Let's use distributive property to get 36x minus 3x squared equal to 81. And what I'm going to do on both sides is subtract the negative 36x and add 3x squared on both sides, just like we did in the problem above, which take your own time. It should be written something like this. 0 equals positive 3x squared minus 36x plus 81. And then we should recognize, all right, what do we do next? Is find a greatest common factor. Do you recognize that one? It better be a 3, not 3x. And you can think factoring is some form of division. 3x squared divided by 3 is just x squared. Negative 36x divided by 3 is negative 12x. And 81 divided by 3 is positive 27. Can you factor that still further? What's inside? Yup. We say 3 times something, since there's no longer a GCF. And what two numbers can multiply to the 27 combined to a negative 12? It better be some form of 9 and 3, where they're both negative. And therefore we have x equals 3 or x equals 9. But remember, these are points, 3 comma 81 and 981. So here's where I'm going to plot those points, 381 and 981. And hopefully you see, visualize those are points of symmetry or matching points because their y value matches as 81. And that's excellent. If you need me to write on my wheel, this is 381. Although that's kind of wasting my time. I could be helping you solve the next problem, but I did it anyway. So let's move on. All right. If you have no problems with this, we have maybe 2 or 3 more. So that's why I'm kind of like rushing it. Here we go. Maybe you want to try this ahead of myself, but if not, let's check it together. The idea is the same. Let's represent an equation for area. Base times height. Base times height or length times width. The width is x over 4. The length is 20 minus x. And again, I'm not going to distribute. I'm going to think of it again. This is factored form. What makes the first something equal to 0? 0 divided by 4 is still 0. What makes the second term equal to 0? When x is 20. So right in the middle of 0 and 20, we have 10. And again, based on what we've done before, hopefully you realize this is a curving down parabola at x equals 10 is its maximum. There we go. And yeah, I'm just going to go ahead and graph it because there it is. I have enough information to do that anyway. And we know that after that, the area cannot be negative. Oh, I do want to point out before I move on, okay? After we have graphed that, you probably, hopefully are still thinking the same. Is this a vertical stretch or a vertical compression? Because I left that idea behind on the last one. Is this a vertical stretch or a compression? And hopefully you realize this 3 is greater than 1, so this is a vertical stretch. And because this is really 1/4 times x, this is a vertical compression. But the nice thing is you don't even need to know those terms to be able to graph that. Look at that. We did that without even discussing it. Next thing is to find the maximum possible area, which we have half of that piece of information. It better be 10 comma something. So let's figure it out right here. Letter C. It is, what is the area when x is 10? And remember that it was 10/4 times 20 minus x. If you need to verify that, there's the equation 10/4 times 20 minus, oh, I meant to write 10. Good thing I double checked that. 20 minus 10. So you simplified in your own at your own pace. Is really 5/2 times 10. And that should simplify to a 25. Check your own work. And that means that we have the point 10 comma 25. All right. 10/25 is 25 is the maximum area, and it happens when x is 10. And lastly, we're going to label 2 points when the area is 20. Oh, sorry, that's not a 2. That should be a 21. Oh, never mind. We're doing letter D. Sorry. When is the area 21? So therefore, we want x/4 times 20 minus x equal 21. But here, I'm not going to go to the trouble of distributing because I don't want to distribute and get 2 fractions. Let's just undo the dividing by 4. x/4 means we're dividing by 4. How do we undo that on both sides? Let's multiply both sides of the equation by 4. So here's how I'm going to write it. x/4 times 20 minus x equals 21. Multiplying both sides is very small to see here. Times 4. So therefore, we get x times 20 minus x. 4 divided by 4 is 1. So we just get 1x. And on the right side, 21 times 4 is 84. If that was confusing, I'm sorry, but you figure it out then. Take your own time to get 20x. Minus x squared equals 84. And then hopefully your factoring skills are strong. 0 equals x squared minus 20x plus 84. This one's a little bit difficult to factor, but it is factorable, all right? So take your time. Rewind if you need to. All right. 2 numbers multiplied to 84 combined to 16. Guess what? It's not 16 and 4. It's going to be 14 and 6. And they're both negative. Yep, that definitely works out. And therefore, we know that the x values are 14 and 6 when the area is 21. So when x equals 14, we should have a 21. X equals 14. The area should be 21 right there. When x equals 14, the area is 21. And we should have a matching point when x equals 6. When x equals 6, we have a matching point right there with the same matching y value of 21. Boom, there it is. Hopefully you're getting better at these. All right. And then 2 more applications of it. I don't know if this is way more advanced, but we're going to go ahead and try and tackle it. We have all the skills to be able to do this. Again, this is another problem that is commonly seen in a calculus course, but we're going to solve it today without using calculus. All right, the main idea is Again, representing some formula or some equation for area. All right, but now it says it's inside this, it's inscribed inside this x-axis and y-axis with this line. So the main idea, think of any point on this line. I'll draw some examples for you. Could be this point or this point or this point down here. If I put a point there, I can make a rectangle. It could be this rectangle. But if the point is here, then it could be this rectangle. Or if the point is right here, then it's this rectangle. Or if the point is down here, then it creates this rectangle. That's what it means by inscribe rectangle. Which one of those creates the maximum possible area? All right. So again, using our knowledge of quadratics, we're going to try to figure out which one of these blue rectangles, and actually I'm going to probably draw it in green to say this is any random rectangle. And that's what I'm going to use the points x comma y. All right. The coordinates of this green rectangle are x comma y. All right. So keep that in mind. Therefore, if that's the case, which one is x and which one is y? Is this x, this distance, or is this y? Is this one x or is this y? And hopefully you can see that this distance right here is the same as this distance down here. Is this one x or is this one y? This is x. And what do we call this one? X or y? This is y. Therefore, this is y. Right? And what's the area of a rectangle that has dimensions x and y? It's going to be x times y. So let's do letter A down here. The area is x times y. X times y. But we want it in terms of x. There's a y right there. And the nice thing is that they give us a formula for the equation of the line is y equals something. So now we can say the area in terms of x is x times something. What's the something? Is this equation right here. Y equals 14 minus x. Perfect. Then we can say, all right, we've seen something like this before. We did it right up here. That was the main purpose for doing all that. We can go straight to the factored form. It's from the factored form to the graph. X equals 0 or 1, 2, 3, 4, 5, 6, 7. This is x equals 14, scaling by 2. X equals 14 and x equals 0. Right in the middle of those two is x equals 7. And hopefully you recognize this is a downwards, curving downwards parabola. That was the reason for doing those problems above. And we know the maximum area occurs when x equals 7. What is going to be that area? The area when x equals 7. And I think that's letter C because we already sketched the graph. Area when x equals 7 is 7 times 7, which is 49. 7 comma 49. Maximum area is 49 when x equals 7. Boom. Look at how easily we were able to solve this calculus problem. The last part, letter D, is not calculus. This is back to algebra. But it's saying when is x times 14 minus x equal to 40? And it makes sense that it should be something smaller than the maximum area. So think somewhere right here. When we distribute, we get 14x minus x squared equal to 40. Like I've been saying all this time, if your factoring skills are strong, you would get something like x squared minus 14x plus 40. Take your time to verify that these two are the same. And when we factor, we get something times something. X times x for the x squared part. And hopefully you think it's some form of 10 and 4 when they're both negative. So either x equals 4 or x equals 10. But the y value or the area was 40. So think 4 comma 40. Or think 10 comma 40. And you should see them match in your picture. 10 comma 40 right there. And 4 comma 40 right there. And look how accurate that graph looks now. With 5 points labeled. Everything we've been doing in the past. This is very advanced mathematics. Congratulations if you made it up to this point. I invite you to try the next one by yourself. If you no longer want to stick around, because you think you digested everything, then have a good rest of your day. But here we go. The rest of you that did stick around, let's solve it, because this is one more level advanced in progression of complexity than the previous one. So again, we still want to represent some area. And I do want you to think this is still the x value. And this is still the y value. So the area is going to be x times y. But this is not in terms of x. We want it in terms of x. The x is fine. What's not fine is the y. We want to replace that. And again, the nice thing is we were given this equation. 24 minus 2x is y. And now this is only interpreted in terms of x values. So there we go. We got the first part done. And from here, we can go straight to the graph. We know that x equals 0, or x equals, this is 0, 0, or 24, 0. Whoops, I missed something. Hey, give me a second. That's not right. It's not right. I didn't read that correctly. It's 24 minus 2x. Nice that I caught that. All right, so hopefully you were yelling at the screen like, no, bro, that's not correct. And here, instead of distributing, I noticed, look, the inside part does have a common factor. What is the common factor of 24 and 2x? Hopefully you recognize that this is the same as 2 times 12 minus x. So that's the way I'm going to do it. And this becomes, and again, take your time to check your algebra. This becomes 2x times 12 minus x. Oh, and that's way nicer to graph. The x-intercept doesn't change, but this one does. It was not 24, it's 12, 0. All right, so be very careful with that. That's excellent. I know that it's a curving down parabola. Hopefully that you can see that as well now. We've done so many of these at this point for you not to see that. But if not, it's fine. Just ask somebody for help and keep trying. You'll get it, bro. Don't feel down on yourself. We know the maximum happens when x equals 6. And we need to do a little bit of algebra or arithmetic to figure out what that maximum is going to be. That will happen when we have area when x equals 6. Let's make that a little bit more legible. That's going to be 2 times 6 times 6 in whatever order you want to check that, because there's a 6 here and there's a 6 here. And therefore, this becomes area equals, I'm just going to write the point. It's going to be a 6, 72. 6, 72. Yep, that's right. Hopefully you got that too. And that's the calculus problem solved. The last one is the algebra problem, back to algebra. And that might be more intense for you guys, and even for myself. The area equation was 2x minus, my bad, times 12 minus x equal to 54. Remember that here we want the area equation equal to 54. We want to set the area equal to 54. Let's do distribute. We get 24x minus 2x squared equal to 57. I mean, 54 still. I don't know what I was thinking. 54 still. We didn't distribute anything there. I don't know. Anyway, pretend you didn't hear that. 0 equals 2x squared minus 2x squared, 24x, plus 54. And let's factor out the greatest common factor, which will give us inside an x squared term, minus 12x plus 27. So therefore, we should get 2 times something, x times something for the x squared term, and some form of 9 and 3, where they're both negative. So we're going to get the points 3, 54 and 9, 54. I hope you're okay with me skipping that step, because I'm afraid this video is pretty long already. And let's plot them, matching points, 3, 54, 954. That should look pretty nice on your graph as well. That's another example of matching points or points of symmetry. All right, that was pretty good. Good time for me, but I know that math is can be something that seems like a long time for everybody. So I thank you if you stuck around this far, and thank you for all your minutes of watching. Hear me talk more in the next ones, and goodbye.